In this section, we cover one of the most useful features in Git, branching. So everything in this section has to do with branching, and branching is really one of the last topics I would say that you have to master and have to be comfortable with in order to use Git day to day. There are plenty of other topics we cover in this course, but those may not come up as frequently. Branching will come up on a daily basis, just like committing, if you work with Git daily at least. So we start by covering branching at a conceptual level. What is it? What are the benefits? Why would you use it? And that is going to be critical. I've marked it in yellow, not because it's hard, but it does take up a little bit more time than learning a single command. But I really recommend you don't skip through the videos before the commands. Everyone likes to just get to the meaty stuff, show me the commands. But with branching, it really helps to understand with diagrams. Plus, I introduce a couple of concepts, including something called Git head. You've probably seen that term so far in your terminal. That's also going to be critical. Understanding what head is and the fact that it points to something called a branch reference, and a branch reference points to a commit. All this stuff we cover in these two videos. Other crucial things: understanding the git branch command, the git switch command, the git checkout command. Then I'll say that deleting and renaming branches is important, but not as important as this other stuff. Head and refs behind the scenes, I'm going to say, is nice to have. This is just an explanation of, or it's proof of how some of these concepts work. I actually show you in the .git directory. So it's nice to have. It'll make you a more, I guess, well-rounded or informed Git developer, but you don't need to know it in order to use Git. And then we spend a little bit of time, not a whole lot, talking about branch naming and the issue that came up in late 2020, early 2021, around renaming the default branch from master to main. So that will make more sense once we talk about branches. But I'm going to say it's important, but it's not critical to understand in order to use Git. Okay, so before we dive into branching, let's just talk for like 10 seconds, probably 30 seconds, about how Git works at a very, very basic level. When we make a commit, each commit gets this weird-looking hash, this long series of numbers and letters that is supposed to be unique, that corresponds to the contents of a commit, plus a couple of other things. If you don't know about hashing functions, don't worry. You don't need to understand any of it in order to use Git. I'd say most people don't, who still use Git daily. I will have a video in sort of an appendix at the end of the course or towards the end that goes into some more details about how the hashing actually works, what is hashed together, what hashing algorithm is used. It's called SHA-1. Anyway, all that we need to know is that every commit has this unique hash, this unique identifier that corresponds to the commit, and each commit references at least one parent commit that came before it. So here we can see this most recent commit in blue has a commit that came before it, right? This pink one. And before that came this purpley blue one. And that happens to be the initial commit. It does not have anything before it. It does not have a parent commit. That happens the very first time you commit. So we have this linear history where one commit leads to the next, which leads to the next. But often when we're working on a real project in the real world, we need to work in multiple contexts simultaneously. So imagine I'm working, I work at some company, I'm working on a web application, and I'm trying out two different color scheme variations for a website, and I want to try them both out and figure out which one I like best. And at the same time, I also have been tasked with trying to fix a really horrible bug, but this bug is proving very difficult to solve. I'm actually needing to delete some code and comment stuff out, move stuff around to try and hunt down the bug. So it's not as simple as just fixing a typo. I have to totally destroy part of the code base to find this bug. And at the same time, one of my teammates is working on adding a new feature, a little chat bot in the bottom corner, those things that pop up and you can chat with customer service or something. It's not clear at the moment if our company wants to use that, but he's going ahead and trying it as a bit of an experiment. And then another coworker is adding some new functionality to the search bar, autocomplete, and yet another developer is doing something very different. She's doing a very experimental, radical design overhaul of our entire application layout, but it won't be presented until next month, and we don't even know if any of it will be used after next month. So, lots of different contexts. If we all worked in a linear fashion, one commit after the next, this would be practically impossible. how could we be working on separate things, some of which break other people's code, right? If I'm trying to fix a horrible bug and deleting a bunch of code, removing files, I'm like just making a mess, that's going to be a big problem if somebody else is trying to add a new feature. Likewise, if someone is doing a radical experimental design change on every single view of our application, everything changes. But I'm trying to work on some minor color scheme variations, or if someone's working on adding a chat widget to the bottom right of our screen, those things need to happen in separate contexts because they have implications on one another, and they really need to happen in isolation until maybe at some point we decide to incorporate changes into each other's contexts. So that is where branching comes in. That's exactly what Git branches allow us to do. Branches are a signature feature of Git, and you can kind of think of them as alternative timelines for a project. They allow us to create separate contexts whenever we want. We can try new things, we can work on multiple ideas in parallel, we can experiment, we can break stuff, and whatever we do on one branch will not impact what happens on other branches. Although we can decide to then combine branches, we call that merging, and we'll learn how to do that. But that's something we have to decide to do. Otherwise, if we make a change on one branch, the other branches do not know about it. They exist in isolation. So this allows me to make a commit and maybe make another commit on one branch, and then at any point, splinter off and try something. On this pink branch up top, I'm calling new color scheme. I could try a new color scheme out. But over here, if I switch back to this branch, none of that code comes with me, none of those new commits. So I could branch off again and work on a bug fix, but again, totally separate context. And then I could branch off even further from this bug fix branch and branch further to do an experimental redesign. So now I have at least 4 different contexts. 1, 2, 3, and 4. And this means that, I could be working on this, and maybe somebody else is working on this branch, and somebody else is working here, or maybe someone else is working on this purpley bluish branch in the middle, and working on things, plotting ahead. Well, I'm still stuck here. We're all working in separate contexts. But then a very important part is being able to then combine and merge branches together when appropriate. If you work on a bug fix and you actually solve it, then you want to merge that bug fix into the main code base or into another branch. So we'll learn how to do all of this in time, but I'm going to stop talking for now. In this video, I just wanted to introduce this idea of branching, of having separate contexts. So even though we haven't really used the term branch, we haven't made branches or referenced them in any way, in Git, you are always working on a branch. And we've seen evidence of this. You've hopefully seen this before on branch master, nothing to commit. Or it may not say nothing to commit, but on branch master something. So in any repository, here's my first novel. If I type git status, here we are, on branch master. And you can see the way I have my terminal configured, it also shows me my branch that I'm on currently. It shows master here. That's what that is. So when we learn how to change branches, you'll see that updated as well on this right-hand side. So we're always on a branch, even though we didn't decide to be on the master branch. We didn't create the master branch. It's just there for us. And that's exactly what the master branch is. It's just the default branch name when you make a new Git repository. When we run git init, automatically the branch that we start on is called master. Now, it doesn't do anything special. It doesn't have any fancy powers whatsoever. It's just like any other branch. Every single possible branch you create, they have the same abilities, the same commands. There's nothing special about master except for the fact that it just happens to be made for you. Now, some people do treat the master branch as special in their own project. They treat it as the source of truth, the official project branch, the main branch, where they don't want to mess anything up. So they treat the master branch as like our official working code base. And then I'll try things on other branches, and if they work, I combine them back into master. But again, that is a choice that you make or that specific developers make. From Git's perspective, the master branch is just like any other branch. It does not have to hold the master copy of your project. You can delete it, you can rename it, and in fact, I want to talk about renaming it for a moment. This is a topic that will come up again a couple of times throughout the course. The name on Git and GitHub for the default branch name for a long time was master. However, in 2020, GitHub announced that they were renaming the default branch name from master to main, as part of a larger push by tech companies to try and avoid any potentially offensive language. So GitHub, again, just GitHub, made this change from master to main. With Git, however, what we're using, we haven't touched GitHub yet, Git, the default branch name is still master. And that's why we see things like on branch master. We didn't name it master, it's just the default branch name. However, there are conversations happening, and that may change in the future, and I will also show you how to change the default branch name if you want to do this. It's easy to do, but I'm going to wait until we talk a little bit more about branches. I don't want to talk about renaming and changing branch names before we even really understand what they are. So we will come back to this, but I want to bring this up because on most of the documentation, tutorials, videos that you see out there, you will see the term master branch as the default branch name. And over time, more and more people will likely adopt main. So we'll put a pin in that for now. And my slides are going to continue to use master just because it is what your Git is going to show you, branch master. But once we get to GitHub, we will use main. Okay, so I mentioned that there's nothing special at all about the master branch. But a lot of companies or a lot of people treat it as your main branch where things should always be working. It should be the main copy of your code base or of your project. So you could then make a branch to try something experimental and make some commits and test something out. And then if you like that, you can incorporate it back to master branch, or you can abandon it and just move on and keep working on your master branch and just not incorporate this experimental branch. This is an approach a lot of people use. It's a very common workflow, and we will actually have a section on Git workflows and collaboration patterns. But this is a very, very common one. It's called feature branching or creating feature branches. So you have your main or your master branch, which acts as the source of truth, and then you add new feature branches and merge them back in when it makes sense. So here's another version of the same thing. We have Ethel and Fitz working on their own branches, and then our master branch or the main branch where their changes can be merged in. But for us at the moment, the only significance of the master branch is that it just exists. So next, we're going to learn how to make our own branches and how to switch between them. But before that, we're actually going to talk about this right here. What is this thing? Head arrow master. So there's one more concept we need to get out of the way before we can talk about creating branches, which is this thing right here, head. You've probably seen this before when we type git log, for example. Every commit shows up, hopefully that's review. And in our case, we see at the most recent commit, the top one, this thing, head arrow master. So what exactly is that thing? Head in all caps, what does it mean? Well, it's just a term in Git. Specifically, it is a pointer that refers to our current location in the repository, and it points to a particular branch reference. So there's some terminology in there, branch reference, we have not discussed. So I'm going to break it down here. I like to think of branches as bookmarks in a book. We can have a whole bunch of different bookmarks, different places in a book. So let's say this is where I left off in the book, and this is where I'm sharing it with my friend. This is where Fitz left off, and this is where Ethel left off in the book. 3 different spots. At any given point in time, only one of those spots can be open, right? We can't have the book open to multiple pages. So only one is active, only one is being read or being viewed. It's actually open to that bookmark. So that is what head refers to. Head is our current location that we are viewing or that we are checking out is a common term you'll hear. So in our case, we haven't done anything with head. We haven't made any branches. So head always is referring to our master branch, the last commit on our master branch. And that's what we see here. Everything's on our master branch. Head refers to master. That's what this arrow means. Head pointing to the master branch. And this is all master branch. This is what we call the tip of the branch. It's the last commit, the most recent one. So head refers to the branch pointer. I know it's crazy terminology. Then, if I had more branches, if I switched to a different branch, like I switched to Ethel's branch, head points to the tip of Ethel's branch. Or I take a look at Fitz's branch. I've switched there. This is what I have open in our massive book. This is the thing I currently have active in my repository. Head points there. I believe the term originates from a playhead, I think is what it's called, on an old tape machine or tape recorder. I don't know, I'm out of my depth here, but it had some analog meaning in the real world. So one more diagram to make this clear. Probably won't make it clear just yet, but more practice will. I want to reiterate, head is a pointer. It's a reference to a branch pointer. And a branch pointer is where a branch currently is. It's like that bookmark in a book. We can have a whole bunch of branches, and each one has a branch reference that just refers to where that branch is. So let me demonstrate this. We start on our master branch. That's where we are now on every project we've done. We're on master. Head points to master. I do some more work. I make a commit. I'm still on master. So this branch pointer updates to my new commit. And head stays the same. It's still master. But then I decide I want to try something experimental. I'm going to make a new branch. So I want to try adding a dark mode to my website. So I make a new branch. We'll learn how to do that soon. Dark mode still refers to the same commit as master. They are at the same point, right? They are two branch references pointing at the same thing. And head points to dark mode, which means I'm on the dark mode branch. So now if I make a new commit, I do some new work, things diverge. Master stays where it was. It's pointing to this commit. But dark mode now has a new commit it refers to, and head still points to dark mode. So if I do new work, I'm on dark mode. That's the branch I currently am on. So that new commit is on dark mode. This dark mode pointer updates to this commit instead of that one. And then I can switch back at any point. I could go back to master. Remember, I think of it as a bookmark in a book. So we still have that bookmark. That's what this reference is. And I can open to that page by switching over to this branch. Head is pointing to master. And I could go back to dark mode, go back to master. Head is just the thing that is currently open, that I'm currently checking out in my repository. So we could have hundreds of these different branches. Each branch has a branch reference pointing to where we left off. That's really the key takeaway here. A branch is just a reference to some commit. And as we make more commits, even if we're just on the master branch, I make a new commit, that master pointer now reflects that change. It updates to point to that new commit. So over here, originally when this was the only commit, master was pointing to this commit, and then to this commit, and then to this commit. And now it's all the way up to this commit here. They're all in the master branch. This is the tip of the master branch here. And then at any point, we can create different branches and splinter off into different directions. We can have all these different branch pointers referring to different commits, and then switch between them by moving head. All right, so conceptually, it's kind of a dense video, I know. I think it will make a lot more sense when I show you how to do this with the relevant commands, which is coming up next. Okie dokie, it's time to learn our first command that has to do with branching, and it's a pretty simple one. It is git branch, git space branch, nothing else. This will just give us a list of our current existing branches in a repo. So it doesn't make a new branch, it doesn't switch branches, it just shows you the current branches. In our case, we haven't made new branches, so we won't see anything except master. So I'm on my first novel for now. I'm going to make a new repository in a moment. If I type git branch, I see one branch, master. And to get out of here, just like with git log, I type q. Now I'll show you a different project. This repository has a couple more branches. If I type git branch, you can see them all here. Birds, birds of prey, California mammals, hawks, mammals, master, no animals, owls, stash test. I was testing something out there. You can see though, there's a bunch of branches, but the one that is active has a little asterisk next to it. That's the branch we're currently on. So we see I'm on owls. And again, I can type Q to get out of here. So here on the My First Novel project, we only have master. I never made that branch. And it's the only branch we have, so we're on it. We don't really have a choice right now. But next up, we're going to learn how to make a new branch. All right, so next up, we're going to learn how to make our first branch. And we actually use the same command that we just saw, git branch, except now we add on a branch name. So git branch with a branch name will create a branch with that name versus git branch without anything else, just lists the current branches. So git branch, branch name. And your branch name, we'll talk a little bit more about later, but it shouldn't include spaces. Let's just start with that. And generally, you want it to make sense and be informative, but you don't need to write, a whole sentence to explain what the branch is. Also, this simply makes a branch for us. It does not switch to the branch. So I'm on my master branch here. As you can see, head points at master. I have 2 commits on the master branch. When I run this command, git branch bug fix, that makes me a new branch called bug fix. It's based off of the head where I currently was. So it points to the same exact spot. But I have a new branch. I have not switched to it. I'm still on master. So I'll demonstrate this to you. Let's make a new branch. But first, I'm actually going to work on a separate project, a separate repo. Instead of working on the novel we were writing, The Great Gatsby, I'm going to make a new repo. I'm in a folder. I'm just calling it branching. And I'm going to make a directory. I'm going to make a road trip playlist folder. So often when I'm teaching this stuff, I'm torn if I should do something very easy to follow along with, something simple to understand, or if I should do something realistic. I'm going to try and do both, but I'm going to start with the super simple, easy to understand project. So it's not really a project. We're going on a road trip, and I want a playlist of songs, and I'm going to use Git for whatever reason to track those songs, and I'll make some different branches. So I'm going to start by making my repository. So I'm in a folder, road trip playlist. I'm going to run git init. So I have an empty repo. I know that I wasn't in a Git repo, but I should have checked to see with git status, but I know that I wasn't. And then I'm going to go ahead and make a file. I'm going to call it playlist.txt. And I'll open this up in my editor. Okay, so here it is. I'm just going to start by adding a very simple heading like song-artist. So it's just the header heading for the playlist, right? I'm going to add that file, git add playlist, git commit. I'm on the master branch, of course, just by default. Add playlist header. All right, we type git log. We see head is pointing to the master branch. Now I'm going to add 2 songs, just 2 ABBA songs to start that I happen to like. There they are, SOS, great song. One of Us, also great song. I'm going to add those. I just want to have 1 or 2 commits on my master branch. So I'm going to do git add playlist, git commit, add 2 ABBA songs. Alrighty, so I'm on the master branch, right? Head points to master. We have 2 commits. Now, let's make a new branch. For whatever reason, I decide I want to make a different playlist based on this one that only contains oldies. So maybe I'm not sure, what I want on my main playlist. So I'm going to try a couple of options, and that's exactly what I'm going to do, is make some different branches. And I'm going to make a branch called oldies, and it's just going to include songs that are, they're not technically what the radio would classify as oldies, but let's just say anything from before like 2000, which I recognize for most people is not oldies. So to make a branch, git branch, and then a branch name. So let's make that oldies branch. Git branch. I'll make this full screen. And then actually before I do that, let's just do git branch. We're on master. It's the only branch. Now if I do git branch oldies and hit enter, doesn't seem like anything happened. I'm still on master, right? If I type git status, I'm still on master. No surprise there. It doesn't switch us over. But if I type git branch, we do see we have a new branch oldies. We're just not on it. Head is still pointing to master. You can see that again. Type git log. Head is pointing to master, but now we have this new reference, oldies. It's at the same commit, right? 2 branch references pointing to the same thing. We just happen to be on master. So we're at this stage. 2 branches, they're both referring to the same point, the same commit, and we're on master. So to switch branches, there's a command that we can use called git switch. So this is actually a newer command in Git. I'll do a separate video on the older command. We used something called git checkout to do the same thing. We'll talk about that. It's still used in other contexts, but git switch was introduced to switch between branches. So git switch and then a branch name. So in our example here, if I do git switch bug fix, head is now pointing to that bug fix branch. It was on master, now it's on bug fix. So in our case, we have this oldies branch. We are not on it. We see that we're on master. I type git status, we're on master. But if I do git switch oldies, and I do need to spell it correctly. So if I reference something that doesn't exist, it tells me there's no branch with that name. But if I do git switch oldies, hey, switch to branch oldies, my terminal shows oldies over here. If I type git status, on branch oldies, and if I type git log, you can now see head is pointing to oldies. Still the same commit though, I haven't done any new work. However, if I do some new work, I make a new commit here. This is the oldies playlist, so what should we add? Let's add two great George Jones songs. He Stopped Loving Her Today. Oh, great song, great song. Okay, so I'm gonna save, and I'm going to commit. Now, when I commit here, remember, I'm on the oldies branch. So git add playlist, git commit -m add to George Jones songs, just like that. And we just made our first commit on a new branch. We're on the oldies branch. And if I type git log, we're going to see something we haven't yet seen. We see head referring to oldies. That's what we expect to see. It's our most recent commit. That's where oldies is, because we're on the oldies branch. But we see master now has been left behind on this previous commit. Master is still, remember this idea of a bookmark in the book. It's still bookmarking this commit. This is master. This is oldies, and we happen to be on the oldies branch. But I can switch, as we've seen with git switch. So if I switch right now, this is what we have on our oldies branch. If I switch over, git switch to master, take a look. Now we have just two lines, just two songs rather. We don't have the George Jones stuff that we did. If I type git log on the master branch, we only have these two commits. Add the playlist header, add two ABBA songs. But when I switch back, git switch to oldies, we now have our two George Jones songs in addition, and I type git log, we have that extra commit. So that was just our first example of making a branch and switching. We will get more practice in the next video, but just to remind you, git branch on its own will list branches. Git branch with a branch name makes a branch, and then to switch to a branch, we use git switch followed by the branch name. In this video, we'll continue to make some more branches, and I'm also going to show you another way, another command we can use to make and switch to a branch. But first, I want to pay special attention to this part of the first paragraph here. Use git branch with a branch name to make a new branch based upon the current head. That part is super important. It tells us that where we are, what head is, when we create a branch, impacts the branch that we create. So the location, the current branch we're on when we branch, is very, very important and makes a huge difference. So for example, here I've got my road trip playlist. I don't want to call it an app, but our repo, just from the previous video. And I'm currently on the oldies branch. I type git log. I have the commits from master, these two. And then I have the new commit I added on the oldies branch. So I'm going to add, how about two more songs, George Harrison songs. Okay, My Sweet Lord and What Is Life by George Harrison. And I'm going to add and commit those. And I'm actually going to do it in a different way I haven't showed you. -a-m is basically a one-line way of adding all on-stage changes. So git commit -a instead of add and then commit. And then I'll provide my message. Just add two George Harrison songs. All right, so now I have another commit that I've added to the oldies branch. So if I branch right now and make a new branch, let's say I make a George's branch. I want to make, I guess a playlist that only includes songs by George's. I can do that. I'll branch from the oldies branch. That's where I am right now. So I can do git branch George's. Okay? So I made that branch. Of course, I'm still on oldies. I haven't switched over. But if we look at git log, we see that both oldies and my new branch George's, they are both referring to the same commit. They're at the same spot. The same page has been bookmarked with two different bookmarks. Head is currently pointing to oldies, but if I want to switch to George's and make a commit on George's, of course they will diverge. So if I switch over, git switch to George's, we go to git log. Only thing that has changed here is that head now points to George's. And I have all those commits from the earlier oldies branch on George's. So now I can do a bit more work. I'll add, I'll add 2 George Michael songs. Okay, so there we go. Careless Whisper and Faith by George Michael. I'll just add and commit them. Do the same thing, -A-M, add 2 George Michael songs. And this, of course, only goes on the George's branch. That's the branch I'm currently on. So now, if I type git log, what do we expect to see? Head refers to George's, because I'm on the George's branch, and I have this one commit that only exists on the George's branch, and the oldies branch was left in the dust back here, right? So I could switch back to oldies, git switch, oldies, and we see we lose those 2 songs. Also, I actually left in those ABBA songs, so I should switch back to George's, and I want to delete those ABBA songs because they're not created by George's, and unfortunately, we're only allowing George's here. So now I'll do another git add and git commit, or just the short version. I'm on the George's branch, so don't forget that. Remove 2 ABBA songs. All right, so now git log, I have these 2 new commits on the George's branch that I'm currently on, plus all the other commits from the oldies branch at that moment in time when I split. So just at that moment in time, if I do more work on oldies, it does not impact George's. Okay, so now I go back to oldies, git switch oldies, and we see ABBA is back, and we don't have George Michael. If I go back to master, almost everything's gone. We just have ABBA. So if I make one more branch from here, just as a quick demo, it's going to be based upon master. That's where I currently am. So I know I'm beating this dead horse a lot, but it's really important. Where you branch from matters. And if I make a new branch, git branch, what should this one be? How about just an empty playlist? Git branch empty playlist. Okay, I now have this branch referring to the same spot as master. And now I'll switch over. Git switch empty playlist. And here we are. So now I can delete everything if I wanted to. Git commit -A-M empty out playlist. And there we go. If I look at the git log, I only have 3 commits, the 2 from master and then the 1 new one. Anyway, this has been a long demonstration, but I just wanted to show it does matter where you branch from. So we go back to master. If I, git switch master. Okay, we have ABBA. If I go back to George's, git switch George's. There we are. And if I git switch back to empty playlist, that's all we've got. Okay. All right, so next up, I want to talk about a different command you may come across that we can use to switch branches. It's called git checkout. You can see it here. Git checkout with a branch name will do the exact same thing as git switch with the same branch name. It just switches us to whatever this branch name is. So this command, git checkout, existed for a long time. It still exists in Git, and it does a lot more than just switching branches. So it's kind of a Swiss Army knife of Git. It doesn't do everything. I guess neither does a Swiss Army knife, but it does a lot more. And for a lot of users, this was confusing, and just it felt like it did too many things. So git switch was introduced. It's newer. So the command we've been using, git switch, is the newer, fancier way of switching branches, but this is the old school way, and it still works. And I'm showing it to you because you'll still see this for sure all over the place in documentation or on blog posts, YouTube videos, that sort of thing. Coworkers might use git checkout to switch branches. Plus, git switch is still liable to change, although it's been around now for a little while. I don't expect it to. So let me just demonstrate this. I'm on empty playlist. We can see I've got my 4 branches. Let's switch to oldies. So instead of git switch, I'll do git checkout oldies. And it's the same behavior. I'm now on the oldies branch, as we can see there, and my file has been updated to reflect what's on the oldies branch. So that's kind of all there is to using git checkout in that one particular way. But remember, git checkout does a lot more. You can read about it on the docs, although I really recommend you don't read it right now. Just know this first part. We can use it to switch branches, but then there's this whole other thing, restore working tree files. look at all the different options for how we use it. We will get into checkout later on. But in terms of switching branches, it's very, very simple. With that said, I still prefer git switch. Now, another thing that we can do is instead of creating a branch and then switching to it in 2 separate steps, we can do it all in one go. We can do it with git switch if we add -c as an option for create. So we provide a branch name, and it will create that branch and then switch us over to it all at once. So this can be pretty useful in my opinion. Let's make a new branch let's go back to master maybe. So we'll go back to master. We'll use switch or checkout, it doesn't matter. All right, so I'm gonna make my new branch with this shortcut I showed you, git switch -c, and then a branch name that doesn't exist yet. So I'll switch, I'm gonna call it recent-ish music, like that. And notice it made it, and I switched to it. So without the -c, it would give me an error, right? Just like this error. It can't find that branch to switch to, but with -c, it makes the branch for me and then switches over. And I'll just add 2 songs for some recent music. I'll remove ABBA. Phoebe Bridgers, by the way, if you don't know her, very talented singer-songwriter. And I'll just add and commit that. I'll do it in 2 steps this time. Okay, add 2 Phoebe Bridgers songs. There we go. And that's kind of all I wanted to show you here. Now, there is an equivalent command if you use git checkout, but unfortunately, it's git checkout -b, B as in boy, B for branch. It's very confusing. I don't know why they went with -b, but it's just how it works. If you want to make a branch and check it out in one go, git checkout -b or git switch -c. And again, I prefer this, but you'll see git checkout used. All right, so we've got some pretty good practice now, making branches and switching, making new commits on separate branches, switching between them. Hopefully it's clear, or at least becoming clear how this all works. One thing, though, that my limited example has not illustrated is that we can have as many files as needed, right? I don't want you to think that branches exist on a per file basis. We do see this one file being updated, but I could make another file on one of these branches, and Git will make sure that it exists on that branch and does not exist on the other branches, or Git will update all relevant files and folders depending on the branch. So it's not limited to just one file, even though my simple demo has been. All right, so that's it for this video. This is going to be a very quick video. I just need to explain one thing that we haven't run into yet. If I'm on a branch and I have some work that is not currently committed, so let's go to the oldies branch, git switch oldies, and I'll do some work here, like I'll add 2 Van Morrison songs, great songs, and It Stoned Me and Caravan, so I'll save those 2, but I'm not gonna add and commit. So over here, I see git status, I modified that. I have changes that are not staged. There's work on this branch that has not been committed. If I try and switch branches right now, let's see what happens. Let's go back to the, how about our empty playlist? Git switch empty playlist. And what does it say? I get an error. Your local changes to the following files would be overwritten by checkout, playlist.txt. It's telling me that the work I have done right now that I have not yet committed, which is right here, if I try and switch to a different branch, it's going to be lost because it's not committed. This branch doesn't know about it. There's not going to be a bookmark for it in the really large book before we change pages. So it says, please commit your changes or stash them. We will learn more about stashing in just a couple of sections from now. So for now, that's not an option. For now, our only option is to commit our work or just delete it, I guess, and not make those changes. So I am going to commit that. Git add, playlist, git commit, -m, add 2 Van Morrison songs. Just like that. And now I can switch. So I can do the same command to switch to empty playlist, no complaints. So if you run into an issue like this, hopefully you understand why now. Git is warning you, you're going to lose those changes. You either need to stash them, which we haven't learned, or commit them. Now the last example I showed you, we had changes that were in conflict, right? When I tried to switch branches, we were working on the same file, this playlist file, and they were in conflict. And so Git yelled at me and said, hey, I don't know what to do. We'll learn more about conflicts when we get to merging. But sometimes that's not an issue at all. So if I make a new file, for example, I'm on the oldies branch. Let me make a new branch here. Git switch -c, and this branch will be, I don't know, how about chicken? I'm going to delete it. A chicken branch, okay? And on this chicken branch, I'm going to make a new file entirely called chickens.txt, and I'll put some of my chickens in here, like Stevie Chicks. Okay, so I have this new file no other branch has, but I haven't added or committed that file. And so now if I switch again, let's go back to oldies, git switch oldies. Previously, at the beginning of this video, we saw that Git yelled at me when I tried to switch, and it says, you can't switch. You have changes that are going to be overwritten. They're in conflict. We don't know what to do. Please stash or commit them. But this is going to be different because no other branch has this file. There's no way that it's in conflict with anything. So what actually will happen is this file is going to come with me. I'm now on the oldies branch, and I still have chickens. Do you see that? The file's still there. And it came with me, and it still says, hey, there's this untracked file. You haven't made a commit with it anywhere. It's just going to follow you to every branch you go to. So for now, I'm just going to recommend we always add and commit changes before we switch branches so that we can avoid this. But of course, like I said, we're going to learn how to stash changes very soon. First, we're going to learn about merging. But I just wanted to call your attention to this behavior. When you switch branches, sometimes if you have unstaged changes, they will come with you. Other times, if they're in conflict, Git will yell at you. So just know that. Okay, in this video, I want to talk about deleting and renaming branches. So this is something you probably won't need to do all that often, early on at least, but if you work professionally or you work on a large project where there's tons of branches and you are constantly making new branches and then merging them in, again, we haven't talked about merging, but it's really common to work on something and then merge it in. You don't want to just have this extra branch for no reason. So you can delete them. Let's talk about how you delete a branch. You use the git branch command. Git branch does a lot. We've seen it shows us a list of branches. It also creates a new branch, and we can delete using git branch with the -d option. So -d or -- delete deletes a branch. Now it tells us this message here, it must be fully merged, blah, blah, blah. We will learn more about what this means shortly. We haven't talked about merging. But if I try and delete one of these branches, for example, let's make a new branch. So I'll go full screen here. Where are we? We are on empty playlist. It's an empty branch. Let's go to, I don't know, the Georges branch. So git switch Georges. And then let's make a new branch, and I'll use our single line version, git switch -c to create a new branch. And I'm going to call it delete me because I want to delete it. Okay, so we're on this new branch, delete me. And to delete it, I use the -d option on git branch. So let's try it. Git branch -d, and then I specify the branch to delete, which is delete me. I'm going to run into a problem. I can't delete the branch I'm checked out at, so the one that I'm viewing, right? I'm on delete me, I can't delete it. So if I switch branches, let's do git switch master, and I try running that again, now I get a different message. It's not fully merged. If you are sure you want to delete it, run git branch -d, which is equivalent to adding in the --force option. In other words, allow deleting the branch irrespective of its merged status. So in this case, that's fine. You want to be confident in what you're deleting and that you actually do want to delete it, because without GitHub, without any sort of backup, which we don't have at this point in time, if I had a lot of work on this branch and I actually delete it, it's gone. But for this demonstration, I'm fine deleting it. So git branch _D, delete me. And now it's gone. So we can see here, there is no delete me branch. All right. Now, another thing we might want to do is rename a branch. And this is something we definitely will be doing when we get to GitHub. We could rename our master branch to main to play well with GitHub. But also, it's a common thing to do if you're unhappy with a branch name or you just want to change it and give it a better name. The way that we do it is somewhat hard to remember. We use git branch, the same command. However, the flag or the option that we use is -m. And that seems somewhat confusing. It doesn't, it should be -R for rename or -N for name, but it's actually -M for move, but it's move/rename. So all that we do if we want to rename a branch is first change to the branch that we want to rename. So this is kind of confusing because to delete a branch, we had to go anywhere else but that branch. We could not delete from the branch. But to rename, you have to be on the branch. Again, it's just kind of weird, but you don't have to do this that frequently. So what branch should I rename? How about instead of recent-ish music, I just want to rename it to 2000s. So music from the 2000s, because recent-ish implies something somewhat, pretty recent, but maybe I want anything from the 2000s. So I'm going to switch, git switch, and I'll do checkout this time just to mix it up, show you both work. Recent-ish music, I switched, okay. And now I'm going to rename it with git branch -M, and then my new name, which will be 2000s, okay? And we can see already it changed to 2000s over here. If I type git status on branch 2000s, git log, we see that head is pointing to 2000s as the branch name. It's the same branch that I was on before. The same two Phoebe Bridgers songs are here, but it's been renamed from recent-ish music to 2000s. So I'll do, I guess, one more commit. Here are two songs by a great group called Motorrat, and I will go ahead and commit -A-M just to do it in one go. Add to Motorrat songs. All right, and so that only exists on the 2000s branch. It no longer is called recent-ish songs or recent-ish music. Okay, so that's how you can rename a branch. It's -M. Where are you? Where did I do it? Right here. It's somewhat confusing, but it works. It stands for move. And then we have -D to delete a branch. Two operations you may not need to do all that often, certainly not right now, but good to know about. This video is completely 100 million trillion % optional. Please, if you don't care to watch it, don't. We're not going to learn any new commands or any new syntax. All that I'm going to do is show you a little peek behind the scenes in Git. We're going to take a look at that .git directory, and I'll show you proof of head, how it works, or the fact that it's just referencing a branch, and that each branch reference is referencing a commit. All right, so let's go ahead and hop over here to our road trip playlist. We are on this 2000s branch. Let's go back to master. So git switch master. And on master, it's very simple. We have two commits, and that's it. And we can see that head is referring to master because we're on the master branch. And the master branch is pointing to this commit. This is the most recent commit on the tip of the master branch. Let's take a look at this commit hash. It starts with 93E. Let's just remember that. 93ED. 93'd. Okay, so remember that. And now, remember we have this hidden directory called .git, and inside of it, I'll just cd inside, cd.git. We have this thing called head. And head, if I take a look, I'm just going to use the cat command, is referencing this other thing, refs/heads/master. So in other words, this is, I'll simplify it, head is pointing to the master branch. If I switch branches, git switch oldies, whoops, can't do that from here. I have to back out. Now if I switch, because I was in the .git directory, it gets very confused. Git switch to oldies, and now I take a look again. So I'll do cats.git/head. I'm now outside that folder. See this? It now references oldies. So if I switch back to master, and I take a look at head, it's now master. So that thing, that file called head, is just referencing a particular branch. Now this thing here, refs/heads/master, or refs/heads/oldies right here, they actually reference a particular commit. So let's take a look. I'm going to open up the .git directory now. I've opened up the .git directory just in Finder here. And let's take a look at this refs/heads/master. So refs heads, and you'll see there's a file for every branch that I have. And in each one of these files, there's just one thing. I'm going to open it in my text editor. It's just a commit hash. It's just a pointer to a particular commit. And head, in turn, is pointing to one of those branch references. So remember, head was refs/heads/master. That's what it had inside. And then if we look at what that actually is, it's a commit, 93ED. That is where the master branch left off. That's where the bookmark for master branch is. Now, if I switch to the oldies branch, nothing changes in this master reference, right? But we know that my head changed. So we could take a look at that again, cat.get/head. There it is, head/oldies. And if we look at that, oldies, it says the last commit on the oldies branch is 7ffd. And if we type git log, that's exactly what we see, 7ffd, right? So we can see that all over the place. I have this 2000s branch, and it says the last commit on there, 02f4. Okay? And so if we switch to that branch, git switch 2000s, type git log, there it is, 02f4. So each one of these is like a bookmark. It's one of these branch references. So we happen to have, 5 of them instead of 2 in this diagram. Each one refers to a commit. It just stores that commit hash in a file. And then head changes. This file right here changes depending on what we have checked out, which branch we're currently on. So again, this really doesn't matter if you understand it or not. In terms of using Git, it's not a big deal, as long as you understand the fact that head is just whatever you're currently checked out on, whatever what branch you're on. But behind the scenes, this is the mechanism. It's just a file, and it references a particular branch reference. We look at those branch references. They, in turn, refer to a particular commit. So pretty simple when you look at it this way. So hopefully this diagram plus this starts to sort of congeal. Branch reference points to a commit. This one points to a different commit. Head just points to one of those branch references. So we can stay on dark mode, or I could toggle back to master. But these stay the same. The branch reference, they both stay the same. Head is all that's changing until I do more work and make new commits. Anyway, it's totally optional. I'm sure I'm boring you to death, so I'm going to stop. Bye. All right, so it's time for an exercise to get some practice with Git branches. So this is going to be a simple exercise in terms of the files we're working with, kind of silly. It's Harry Potter themed, but it doesn't matter if you know Harry Potter or don't. If you just follow the instructions and make the branches when you're prompted to make branches and switch branches when you're prompted to switch, you should be good to go. Now, the theme of this, aside from Harry Potter, is of Harry Potter Patronuses, which are like, I guess, a Harry Potter version of a spirit animal. If you've seen the movie or read the books, the spell Expecto Patronum, I don't even know why I'm going into it. It doesn't matter. Anyway, wizards have their own Patronus, different animals. So you will be putting some animals in files on different branches for different characters. Okay, so again, I strongly recommend you do this on your own. Follow the instructions. You can find this file linked to in the resources for this video. You're going to make a new directory, make a new Git repo inside of it, make sure you're not already in one. Then you'll create a new file called patronus.txt, and you'll leave it empty for now. So this will be on your default branch, the master branch, or if you've changed the default name, whatever it is, main, but for now, the default is just master. Then we'll make our first commit with this message, add empty Patronus file. Then we'll make a new branch called Harry, and at the same time, or in the next line, a second new branch called Snape. Both of them should be based on the master branch. They should contain this empty Patronus file. Then you will move to the Harry branch that you just made. And there are 2 different ways we've talked about for moving to new branches or moving between branches. So I would like you to use the new command. If you don't remember which one is new and old, it's not a big deal. Just use one of the commands that we talked about, and then later on, use the other command that you didn't use. Okay? So on the Harry branch, we are going to put this inside of the Patronus file. Harry Potter's Patronus is a stag, so copy all of this and put it in that file. Save it, add and commit the changes, and then use this message. add Harry's Stag Patronus. And again, this is on the Harry branch. Then you will move over to the other branch you already made called Snape. So this branch, again, should be based off of Master when you made it early on at the same time as the Harry branch. When you move over to that branch, use the other command, the older command, to switch or to change branches. And then open up the Patronus file again, and this time put this in there. Snape's Patronus is a doe, so this is what you'll put in there. Save it, add and commit, and then use this message if you'd like. Then, something different. We will make a new branch based upon the Snape branch, and we're going to call it Lily. If you don't know any of these characters, it really doesn't matter. All you need to know is that Snape and Lily have the same Patronus. So we are branching off of Snape to a new branch called Lily, and then we will move to that branch, to the Lily branch, and we'll edit this file. And we're going to keep the doe in there because they have the same Patronus, but we will edit this little header so that it says Lily's Patronus instead of Snape's. You can leave the doe alone, that's the point. They share the same Patronus, the same form. Then you'll add and commit. You can use this message if you want. So this is on the Lily branch. Then run a command to list all the branches. You should see 4. So just making sure you remember that command. And then as a bonus, delete the Snape branch. Poor Snape. Okay, so if you're still here, I really recommend, I insist that you try it on your own. But if you want to just watch me do it, here we go. So I'm going to make a new folder called Patronus. Let's just do that here. Patronus, I'll cd into it. I'm going to initialize a repo, but first make sure I'm not in one. Okay. So now I have this folder and a new repo in it, and I'm going to create a file called patronus.txt. Patronus.txt. And then I'm going to add and commit with this message, add empty Patronus file. So git add that file, git commit -m. There's my message, and there we go. That's the first bit. Now, immediately make a new branch called Harry and another new branch called Snape, both based on the master branch. I'm currently on master, so that works to our advantage. I'm going to make a new branch called Harry and another one called Snape. Okay, next step. Move to the Harry branch using the new way of doing it. The new command is git switch. So we'll move over using git switch to the Harry branch. And now we see that we're on Harry. Then in the Patronus file, add the following. So I need to open up that file. So I copied all of that first of all, but then I'll use my code shortcut. Code, just do the whole folder. Here's that Patronus file. I will paste that in there. Let me zoom out a bit. Okay. So I'll save that. And then it wants me to add and commit the changes with this commit message. All right. So we'll do a git add Patronus, git commit -m, and paste in that message. Okay, so we should now have 2 commits on this branch. Next, we are going to move over to the Snape branch using the older command, which is git checkout. So we'll do that, git checkout Snape. You could use switch, right? They're both going to work, but I just want you to get practice with both. So I'm now on the Snape branch, as my terminal tells me, and I'm going to put this in the Patronus file. Now, if I take a look, the Patronus file is empty, right? Because I branched off of master before anything was in here. I didn't branch from the Harry Potter or the Harry branch. Okay, I'll save that. And then I'm going to make a new commit with that change and this message. Okay, so git add Patronus, git commit -m on the Snape branch, add Snape's doe Patronus. And then I need to make a new branch based on the Snape branch called Lily, and then move to it. So I could just do git branch Lily. I'm on Snape, and that's where I should be. If I want to branch based on Snape, I want this history. Just to remind you, if I do a git log, 2 commits, add empty file, add Snape's doe Patronus. So if I do a git branch Lily, that will work. Or I can make the branch and switch to it in one go, like this. Git switch -c Lily. And that made it, and it switched me over. I still see add Snape's doe Patronus, right? The file contains the doe. Now I'm going to edit it so that it says Lily's Patronus instead of Snape's. So I'll put that up top, And then I will add and commit. So just copy this message, git status, we modified Patronus. So we add, we commit, and we'll give it that message. Okay, next, and almost at the end, run a git command to list all branches. We should see 4. So what is that command? It's just git branch and nothing else, just git branch. We see 4, I'm currently on Lily. And then, bonus, delete the Snape branch. Oh, poor Snape. Well, to delete a branch, we saw that we used the exact same command, git branch, and then a branch name, but we pass in this -d, git branch -d, and then Snape. That's the name of the branch. Make sure I'm not on that branch. I'm currently not. And there we go. It was deleted. So now if I do just regular git branch, only 3 branches. And that's it. That's the end of the branching exercise. Okay,